The next set of calculations in HydraFLASH are saturation properties calculations. And by saturation, I mean dew point, bubble point, and VLE phase envelope of the system. So, like other calculation modules, when a fluid is defined and it's characterized or tuned, it can be used for performing these calculations. The dew point is basically the point where the first droplet of liquid forms in a gas by either increasing the pressure of a system at constant temperature or decreasing the temperature of the system at constant pressure. And sometimes in a retrograde behavior, that's the opposite. So in HydraFLASH, you can input the pressure of a gas and it gives you the dew temperature, or you can input the temperature of the gas and it predicts the dew pressure of the system. It's the same for bubble point. Bubble point is a point where the first bubble of vapor forms in a liquid. So when you input a pressure for a liquid, HydraFLASH can predict the bubble temperature, which is the temperature which at that very temperature the first bubbles of vapor forms. Or you can input the temperature of the system and it gives you the pressure, the bubble pressure. It's the pressure where at the first bubbles of vapor forms. The other calculation is the VLE phase envelope. VLE phase envelope is basically an envelope which divides the PT diagram into two sections. The two-phase section and the single-phase section. So bubble, there are three different, any VLE phase envelope has three different important parts. First is the bubble line, which in this graph, for example, this phase envelope is a phase envelope of an oil. The blue line is the bubble line, and by bubble line is the line that set the bubble points, the bubble pressures at this range of temperatures. The critical point, which is where the dew line and bubble line intersect, and the dew line. So you can find more information on what is the different regions, where is the single phase gas, where is the single phase liquid, where is the supercritical region, what is the other sections, other parts of a phase envelope. You can refer to any PVT books like Professor Ali Danish book, and you will find the data there. But for perform and as far as HydraFLASH is concerned, for performing saturation properties calculations, you can either perform only dew calculation or bubble calculation, or you just simply do a VLE phase envelope and you know both informations. But the point that we have introduced dew and bubble calculations separately is that it gives you the saturation fluid phase properties as well. So if you want to know what is the fluid phase properties of a liquid at saturation conditions, you can perform a bubble point calculation. VLE phase envelope only gives you the temperatures and pressures, so it only gives you the points, the pressure and temperatures of this graph. But bubble point and dew point also gives you the phase compositions. For example, dew point it predicts the composition of the first droplet of liquid, and the bubble point predicts the composition of the vapor in the first bubble of the liquid, or the first bubble that forms in the liquid, or other phase properties. So when you want to know the fluid phase properties at saturation properties, perform dew or bubble point calculations. And if you want to know only what is the temperature and pressures of saturation, what is the two-phase region, what is the single-phase region, perform VLE phase envelope calculations. Okay, in order to perform saturation properties calculations, like other calculations, we need to navigate to the calculation tab here on the upper ribbon. And then, so you have this section that includes all the calculation modules regarding to saturation properties. One thing that you need to remember from previous videos is that we have included the PVT lab test tuning module, which is a module that is used to tune the model using saturation properties or PVT lab test data. We have included this here. So you will have the VLE phase envelope, the bubble predictions, and the dew predictions. So if you want to perform a VLE phase envelope, let us start with VLE phase envelope. We just need to press this button, and the features of the phase envelope calculations will be appears in this panel. Like other calculation modules, you have a one drop-down menu here, which you have a list of all the compositions you have in this active database, or you can see it here or here. So one drop-down menu you have for all the composition fluids that you have saved on this database. If you remember, we have characterized this reservoir fluid that we take the composition from the Pedersen book. We characterize it, we wax characterized it, we characterize it using SARA analysis, we tuned it with CME data or saturation properties data. We have a natural gas here, we have everything. So if you want to know the phase envelope of a composition, you just need to activate it. So let's activate this one, the natural gas. The preferred units of the PT phase diagram, because this calculation gives you, as I explained, the phase envelope of a fluid, of a feed. So these two drop-down menus specifies the phase envelope, the units of each axis, the temperature axis and the pressure axis. So it's a very simple one. Just need to specify the units. By default, it's centigrade and bar. And then you just need to press run. As you can see, this progress bar is moving. It means that HydraFLASH is calculating. And there you go. So you have the phase envelope here. This is the pressure in PSIG, and this is temperature in Fahrenheit. And you have this phase envelope. So there are some parts of this phase envelope that is very important. The bubble line, the blue line, and the green line is the dew line. This Kirkhonden term, which is the highest temperature that this fluid can be two-phase at. Kirkhonden bar, the highest pressure that this fluid can be two-phase at. The critical point, which is a point that the dew line and bubble line intersects, and also it indicates a point that there is no the fluid cannot be distinguished whether it's a liquid or it's a vapor. You can read about what is the critical point, what is the Kirkhonden bar or Kirkhonden term in any PVT references in the literature. So as you know that, and as I explained, the PT phase envelope divides the PT diagram. So let's call this VLE phase envelope. VLE stands for vapor liquid equilibrium. So this divides the PT diagram into two regions. This region and whatever is outside of this region. Whatever is outside of this envelope. This region, this zone that is inside this envelope is a two-phase zone. Wherever outside of this, you have single phase. So if the pressure and temperature is below critical point, then you have the liquid phase. So here you have the liquid phase. So if your working conditions fall in this region, you have a liquid phase. And anywhere here, all the temperatures higher and pressures higher than the critical point, then you have vapor or less dense phase. So for example, if your working conditions at 30 degrees and 400 bar, for this natural gas is in vapor phase. You can tell by that. The other important things I want to mention is the working with graphs. Let me expand this. What you will find is these 5 buttons here and 2 buttons here. Let's start with these 2 buttons. If you want to export the data, you can use the Excel file. If you press the export Excel, it will open a file, an Excel file. Okay, let me okay. So you see that it is the points of dew line and the bubble line, as well as the Kirkhonden term and Kirkhonden bar and critical point. So let me just close this Excel file. If you press export image, it asks you first whether, so let me VLE image, save. And as you can see, it saves just the image of this phase envelope. Okay, let me close this one. So let's, I will come back to this fit to view. You have this remove graph. If you want to remove any part of this fluid or any graph, any part of the graph, you can use this button. So when you press this one, and a small window will be open. So you will be able to choose which part of this phase envelope you want to remove. Or if you have add another bubble line or another phase envelope or a hidden phase boundary or an asphaltene or wax phase boundaries, you will see the list of all the envelopes and lined, all the graphs in here, and you can choose this one. And I just want to remove the Kirkhonden term, this point. I just select it and then press remove from graph. As you can see, it's gone. If I want to remove the dew line, I just need to press the dew line and then press remove. It will remove the dew line. Okay, so let's remove this point Kirkhonden bar as well, so that so what I now have here is only the bubble line and the critical point. So this remove graph is for removing any unnecessary files that you don't want anymore in your PT diagram. The next button is a clear graph. So when you press it, it clears the whole graph and everything is gone. So let me close this one and then get a graph again. Okay, so there you go. The other one is that, so if you remember that we have chosen the units here, and the units are PSI, G, and Fahrenheit. If you want to change the units to another unit, you just need to come here. And for example, I want to change the PSI G to bar G and temperature to centigrade. And that's it. You just need to press this button, convert graph units. And you press this one. So you want to continue, yes. And you will change it to centigrade and bar G. The other option is add point. This is a very useful option. What it does is you can enter 2 types of information. You can enter any point you want. So you either have an experimental data, you have a modeling, you have a phase envelope, you have a bubble line, you have a hydrate phase boundary, you have whatever it is, and you want to compare the predictions, the graph, with an experimental points. So you can perform a calculation and calculate the graph, and then you just need to enter the experimental data here. You just need to remember the point that is being added to this graph follows the units that is already given in this graph. So, for example, because I don't have experimental data here, but the other one is that you want to indicate your operation conditions, your working conditions. Okay, so imagine that I have this is a natural gas, and I'm working at lab temperatures, 20 degrees, and it's bar G, so it's 0 atmospheric pressure, and I just wanted to know where I am in this PT diagram, and I press add. See, this point is added to here. So now I can see that, okay, I'm outside of the phase envelope, I'm not working in two phase, and my natural gas at these conditions is in vapor phase. The other option you have is just to zooming in. If you scroll the mouse, your mouse has this scroll button, which you can scroll forward. If you scroll forward, it will zoom in, and if you scroll backward, it will zoom out. It's very easy to use. If you want to move the graph to anywhere, you just need to click and hold. You just need to press Control, click and hold. So Control, click and hold, and you can move the graph to anywhere you want. Okay. Now the other one is that you can scale up or scale down the axis as well. So if you hover the mouse on the axis and then scroll forward or backward, it will scale up or scale down this axis. Or again, for this axis, you can scroll up, scroll down. So it's really easy to work with, and it is very useful if you want to change the scales of the axes, if you want to zoom in, if you want to zoom out, if you want to move the graph a little bit. And if you have made the changes and you want to go back to the default state of it, you just press Fit to View, this button. If we go back to the exact same settings, all zooming, everything. So if I zoom in again and then press Fit to View, we'll go back to the same state. The other one is that, as you can see, this is my graph, but I have also two sub tabs that are open. First is the graph, and the second one is the data. In this grid, you will see the calculation tab is PT phase envelope, the composition is the natural gas. This is the composition of the fluid I use. And you can see the critical point, Kirkland term, Kirkland bar, and also the dew line points and the bubble line points. And at the end of it, you can see the calculation settings. You can select any part of it, you can copy it, it will be copied to the clipboard, and you can paste it in a text file anywhere else. Or you can save it to database. When you save this data to database, it will save it on a database, on this active database, and you can have access to it whenever you want. So now I have saved this phase envelope on the database. If I go to the database management tab and go to the results list, I can see this phase envelope. It is saved here. If you want more information about how to save results in database, please go to the Flash calculations video. I have presented an extensive explanation of how it works. I've put many examples, but so if you want more information, please go and watch the flash calculation videos. Okay, so now I can see the phase envelope here, save. Now if I double click on it and I press no, this graph will be here. Okay, so let's close this one. And then you can export it to an Excel file, you can convert units. You're already familiar with how this works. And the export to Excel file, it will export this data to an Excel file. You will just copy the exact same data. You will create an Excel file and write all this data on an Excel file if you want to have it in a separate Excel file. Okay, so you give the name of the Excel file here. You know your preferred path. Can be desktop, anywhere, and or you can just type and then press save. Now my file has been created and all data I needed is here. Okay. Now imagine that you want to compare two different phase envelopes. So this is the phase envelope of this natural gas. Also, I have this reservoir fluid of this Peterson fluid. I want to compare the phase envelope of this natural gas with this live oil. So what I need to do is to activate it, just select it, and then press run. Okay, now let's first calculate the phase envelope of this natural gas again. So this is the phase envelope. So if you want to compare two phase envelopes and see the differences in the shape and basically the temperatures, pressures, dew line, and the bubble lines of two different or two or many phase envelope, and you want to see them in one single PT diagram, what you need to do, you can add graphs to this graph as well. So what you can need to do is just simply select this one. This is the reservoir fluid, this LIVO sample. We take the composition from the Peterson book, and I just simply press run. Okay, so it asks me, would you like to add this data to the following graph? If I press yes, this will add the reservoir fluid T3.7 phase envelope to this PT diagram, and if I press no, it will create exactly the same thing, exactly the new tab, and it will show the phase envelope of the reservoir fluid in another tab. So I want to compare them and I want to see them in a single PT diagram, so I press yes. So now you can see I have two different phase envelope in one single PT diagram. As you can see, the area that this live oil is in two phase, it's more than the natural gas, because natural gas usually at normal conditions at higher than 0 degrees is vapor, but this live oil can be at two phase in a wide ranges of pressures and temperatures. But if I let me calculate this again. If I press no, see what happens. If I press no, it will create another tab and will show the phase envelope in another tab. And then what happens if I calculate another phase envelope, which is, for example, this reservoir fluid, and I press run. Now it asks me which diagram you want to add the new VLE envelope to, graph 1 or graph 2. So I press graph 2 and I just need to press this one, or if I want a separate tab for this new reservoir fluid, I just press the create new tab. So but I want to add this to this graph and I press select tab and I will add this to this graph. So I can compare now the bubble line, the differences, and the dew line, the critical points of these two phase envelopes and these two live wires. Okay, so this is basically the phase envelope calculations. You have the same calculations that like bubble point and dew point. If you want to perform a bubble point calculation, you just need to click on the bubble point, choose the desired units, and then if you want to know what is the bubble point of, say, for example, this reservoir fluid, let me calculate this phase envelope again so that I have it. I have this graph open here. Okay. So I want to perform some bubble point calculations. I'm happy with these units. And I want to know what is the composition of the gas phase at 0 degrees. So I choose bubble pressure because I'm giving the temperature and I want the bubble pressure of the system. So I press 0 and then press run. So it gives me the exact bubble point at 0 degrees. Around 170. And it also gives me the vapor composition at saturation properties as well as its molecular weight and density. Or if you want to calculate a bubble line of a range of temperature. So for example, from 0 degrees to 200 degrees, you enter the start temperature and the end temperature and then the steps. So it can be 1 degrees or 2 degrees. And then press run. Again, it asks me whether I want to add this new line, this new graph to this current graph, and I press yes. And as you can see, this line is exactly the same because I have calculated the phase envelope of the exact same fluid. So the bubble line is this one. So if I remove the bubble line from the phase envelope, and so you can see this is the bubble line I've added. Same thing for bubble temperature. You give the pressure, the point, and it calculates the bubble temperature. Or you can also have a line, calculate a line, it calculates a bubble line. So you can see the data here, the densities of both phases at saturation conditions, and you can have dew point calculation. So for example, you want to know what is the dew point calculations at 400 degrees, gives you the dew point pressure. Or if you want a line or dew temperature, or you want a line between 5 and 100 of dew temperature line, calculates the dew line at this range from 5 to 100 bar. You can see the data here, densities, the temperatures, and the pressures.